Hey everyone. Well, it's long overdue, but finally a follow-up to what I started out to do. All I can say is depression sucks, but I finally found some motivation, so here it is, for better or worse. Hey, this is cool. So why didn't I look at this before? At the very end we can see the action of the hammer, the artificial hammer, the key weight. You can see how down the bottom there it's how the front and back of that plastic bit stop on that edge. We've got the front of the plastic coming through the key there, the pivot in the top. We can actually see that other bit of plastic that's stuck through it doesn't actually do anything. It must be the way they molded it, that little flexible bit in the back there, but I did just notice the weight on the back there is solid, so they've actually made the lower keys feel heavier than the upper keys. You can see how they've cut out a section of the weight to make it lighter toward the upper end of the keyboard. And in the highest note, you can see there's hardly any weight at all. It's very open at the back, and it is very light to touch. That's cool. Very subtle. And you can see how the plastic's rotted away there. So I got out my bit of paper and a pen and went ahead to attempt to model this end piece, which I probably could have drawn a lot bigger just to scale. You know, I just traced around the existing one and then attempted some measurements off that and the page and so forth. And it was mostly good. Busted out the old 3D printer, and that's what we ended up with. The only downside is it's not quite there. There's a little bit off in places, and I think this is actually probably printed exactly right to the point that what I didn't allow for was overhang around this metal frame. So it's not wrong, but it's not right. It's too perfect. But yeah, we're getting there. That's going to be two pieces that I will put one on each side of the metal weight, and hopefully it will marry up. It's a bit hard to see there, but there is actually a hollow. Yeah. I don't know about the pivot point up the top yet. I'll worry about that when I get there. But for now, just because, you know, if you're trying to print this thing, I don't really want a lot of support involved, and just to have like a couple of millimeters of plastic sticking out up here for it to rock on, I'm thinking I could just glue a piece on at the end of it all. You know, bond it with a bit of acetone. It would be plenty solid for what it's doing. So yeah, would be absolutely fine, I think, but we'll find out when we get there. If this works, I've got to print 176, 88 keys times 2, and at 12 minutes per half, it's going to take a solid roughly 32 hours to print that many pieces, which is impressive, and only about 400 grams of plastic, I think. I think I'll try and print at least 4 at once on the bed, just to reduce the setup time between prints. Let's go back to the drawing board, so to speak. Well, after a lot of tweaking, As you can see, I have many iterations of this. Here's the original again. I finally have one, and it looks like it's going to do the job. So I've a very snug fit, very snug, just snug enough around the frame. Now of course I will print two of these mirror imaged, such that you would have one on the other side, and that would build up the overall profile of it, and hopefully that will be enough. So let's just give that a dummy test. So I've taken off the very end one, and you can see the next one in, the operation, how it functions. And here is my print. So I'm just going to feed that in. And set that there. And then so far so good. I think I need to round off this corner. And if we fit the key on and make sure that that moves, and that seems to be doing the business. Need to get the other half printed and fitted and see how well that works. I really need to learn a better CAD package, because 123D design, even though it's fairly powerful, like, I mean, you could do a lot of good stuff with it. Not that I'm ever trying anything overly complicated, but it is no longer supported, and it has a couple of glitches that can cause you to lose all of your work. So save often, and maybe if it feels a bit sluggish, restart the program. Yeah, it's doing the job at the moment, but I think other programs, better, maybe something like, oh, what's the name of it? There's another Autodesk one, Fusion, is it Fusion 360? It's probably got a lot more advanced tools for modifying things, because this is just kind of a pain in the ass if you have to make a change. It would be nice if you could scale the sketches accordingly, but no, I just kind of delete it and redraw it as far as I know. But we're getting there. And hot off the printer we have side B. So let's see how well that will fit. It's a mirror image, it should be fairly good. Hey, how about that? A little bit of stuff. Ah, that is very good. A little bit of spreading going on there, but it all lines up quite well. That's just probably some stresses in the plastic itself, but once we glue that, that will be not a problem. Yeah, pretty good fit. May need to make one side slightly taller just to get the seam together, but it looks pretty good. I'm not sure really. There might be a little bit on the corners. They're a bit fatter, just a printing defect really. But if it was a perfect printer, then they would line up 100%. This little bit here was a bit difficult. I've got it, the shape of it shelled to 1mm. So what shell is if you have a solid piece of plastic, you extrude it to whatever height you want, and use the shell command, and it hollows it all out. And with a value of 1mm, it leaves a 1mm thickness in the walls when it hollows it out, and the side. So it hollows it out to 1mm thick. So the bottom flat is 1mm thick up from the bottom, and then of course you've got your extruded length. So this is 2.5mm wide overall. less that 1 mil gives you 1.5 mil wall height, and that's how that works. Now to deal with that tiny little piece, I had a box formed around it, and it ends up being too wide when you're using that shell function with a mil wall thickness. It won't go in the hole in the piano, it won't go in the hole in the chassis, so I'm not sure even if we need that yet. We'll just see how it works as is, but there are a couple of wings that come off here and they stick out each side for it to just rock on. And they are, as you can probably see there, there's the wing, and it has a bit of a curve to it, and it's designed to rock on that. We will test the function, and I'm thinking I could just print a separate piece like that and just glue it to each side. It would not be an issue if this metal nub was just hanging in the hole. I don't think it would be a huge concern. It may stop the weight from shifting. It's I think a bit of support in that respect, just to keep things central. What's it getting stuck on? I went, did I go too high through there? No. May have an overall width a little bit too wide, which is interesting because I'm only a millimeter. A millimeter. Okay, so the one that is too wide measures at 5.5 millimeters, and hot off the press is hopefully one that's a bit thinner by at least 1 millimeter. I'm hoping for 4.5 total. A little chunk of something in the way there. It shouldn't matter. Okay. Let's get across that one. 4.4, 4.5, close enough. This should fit. Still working on the seam, of course, but that's going to be easy. Okay, let's give that a shot. And it should. It was a bit tight through here, and it slips right in. There we go. That is the action we're looking for. And it looks like the arc at the bottom is good. So that's our action there. If we attach the key, that appears to be doing the business. So how to stick this together? Super glue would probably work, but I have a tin of acetone and a cotton swab, which I'm going to just soak up some. Being very careful with this stuff, it's pretty potent, and just going to run it around the edge, get it all nice and wet. And it's going to melt or soften the plastic somewhat, and it's very fast evaporating, so I'm probably just going to run out. We'll do that and flip it over, see if we can't join it that way and pop something heavy on it. There's a giant block of lead. Let's get that in the middle. Make sure it's off the deck so we know it's on top of it. Give that a couple of seconds and that should somewhat fuse it together. Acetone will melt ABS plastic, which will give you pretty much the perfect bond, as once it's dried, it's like the plastic was never two separate pieces. It literally melts it together. Keep it away from any clear plastics because it'll turn them opaque instantly. How long's that been? How long are we going to need? I'll give it another, 30 seconds and have a look. Okay. Really need to cut that block in half. It's very handy and would still be heavy enough for a lot of things. It didn't quite. I guess it's not flat enough on the bottom. We still have a gap there and there. Maybe it doesn't actually quite meet. Might just run some around the groove there and give that another shot. Get it down in the groove. Should be long enough. How do we do? Oh, it's still not glued here. No, it's not so bad though. Around that part there, it's not like too critical. I'll try and print it a little bit taller sidewalls there, but it's a very snug fit as it is. Maybe one layer, maybe one more layer would do it. Layer height's 0.27 millimeter. Well, that's bonded for... No, it's not. What the fuck? Okay, some parts of it are bonded, I think. Lame. Now with our 4mm wide sample, let's see how that functions. It looks alright. And if we attach the key, that seems to engage really well. Now it does have the chance of lifting up because it doesn't have the little hook in the back. So it can lift up at the top there and come out of situ. Perhaps, if anything, the key is ever so slightly raised as compared to the other ones. Ever so slightly raised, but not enough that you'd really be affected playing. All of them are slightly different level anyway, within like half a mil or so of each other, a mil. But of course, once they're all printed, they're all going to be the same print, so they should be all held at the same level. And you can see how that's engaged into the front there. And there is no play between the upper and lower jaw. It's very, if there is any, it's very subtle. See, there's no plastic clacking noises. It's the same, if any, as the one beside it, so it's not going to be overly noisy to play. So now I just need to do that another 88 odd times, right down the length of the keyboard. I have found a small issue. So if I just pop this in like that. Now this probably won't be too much of an issue with the larger keys, but you can see the weight swinging up and down there. It doesn't always come back down. Alright, so if I do the one behind it, if I let go, it'll come fully to rest. If I let go this one, it's not always coming down unless I do it with a little bit of momentum, and then it sort of comes back down. But it is getting a little stuck just in here where it slides on the key. So just in the jaw in the front, it's not able to go all the way back into the center of the jaw. It's just getting a little stuck there. So I'm just going to open that up a little bit in the back because it's quite alright in the front. So just having reprinted the front jaw, and if I slip that in to there, we can see it moves quite freely in and out of there. It sits right into the back. There is about probably 0.2 of a millimeter up down slack, so it's not a perfectly snug fit. And if I get the original one has a similar amount of slack, so we're in ballpark. So now I just need to print the whole shape, do one more test fit, and I think we might be in business. And we can then print 88 odd sets. Yay! So we have that one together. In this particular one, I've also printed the little locking tab that comes up behind there. It is quite flexible, so you can push it in to release it. But no, not so much a locking tab as it stops it from, kind of stops it from coming out and lifting a little bit as well. So just need to lock that into there. But yeah, that little locking piece stops it from basically coming out, really, I suppose. You might not need it. It sort of sits in there quite well, but let's just try this and see how it's going to behave. Ah, that's a lot better. So looking at that, when I release that, there's no sticking, and there's no, like, as far as mechanical noise, it's pretty much as quiet as the original. Winner, winner. Now, I've just got to do that another 87 odd times. Now, to bond the two pieces together, I'm just using a peg to hold the seams close, and acetone. Just loading up a cotton swab of acetone and letting it run down in the gap there. Try not to get it all over your peg because that's also made of ABS and it tends to want to melt. Just get it down in the groove like that, and then a couple of pegs. But acetone works pretty quickly. It melts the plastic pretty readily, so it doesn't take too long. I mean, given how long it takes to print, we can have one glued together while waiting for the next one to print pretty easily. I guess the question becomes, do I take them all off and then clean them up and then put them on, or do I do them one at a time? I'm gonna have to take off the white ones around the black ones. Obviously that's kind of trapping it in there. But other than that, I should probably be able to work my way along the keyboard. I mean, that does, if I take them all off, then they're going to have to sit somewhere and make a mess. If I leave them where they are and do them one at a time, it keeps things in somewhere to be, I suppose. So I'll just do that. We'll see how that goes. Hopefully that'll do the job. I'll start with the end one, and there's a couple of keys that are still in original mint condition that haven't perished. How many have we got? 1, 2, 3, 4, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Well, there's almost 20 keys that haven't perished, which is interesting. And I because they're still original and perfect, I kind of don't want to do those ones. I could always come back and revisit them if they ever did fail. But I suppose there's no point destroying something that's good. But that still leaves, 70 odd keys that are bad. So, yeah, I guess we'll see how this goes. I had to make a slight tweak to the design because the overhang, the plastic was hanging more than halfway over the width of the weight, so it was allowing for some movement when the two were clamped together. There was like a gap in the center, but now I've tightened that up a bit. It's much better. Now we can start bonding that together. So if we start with the top edge there, a tub of acetone. Now you want to be careful not to drop acetone on anything plastic. I don't know if I've probably said that before. It will destroy anything. Which probably brings me to another point. If you're using a cotton swab like this to apply it with, you probably don't want to use the cotton swabs that are made of have a plastic center, because they will dissolve as well. Just clamp that together and making sure that there is, I mean, the tolerances aren't perfect. It's 3D printing is not exact unless you have, a decent setup. But there's always, when you're printing small things, there's always, plastic doesn't necessarily sit perfectly flat. It can swell a little. Yes, if your settings aren't perfect like mine, you can have a little bit of over extrusion. So nothing's going to be perfect fit. But anyway, I'll just make sure that the it's lining up perfectly in the jaw, so it'll not bind at all. It's mostly there, and we'll let that dry, and I'll clamp the bottom side as well while I'm at it. But these cotton swabs have a you get the ones with a cardboard or a wooden center. Too easy. I'm not sure how fast the stuff evaporates. I suppose I could pour some out into a smaller container to make it easier to work with. The printing bed sits at 110 degrees while printing. I find that you have to let it cool off to about 80 degrees before the plastic will detach suitably. So this one's just finished, and the plastic is quite soft, of course, so if you tried to peel it off the bed too soon, it can actually deform the shape, and it will stay that way if you're not careful. But if you let it cool down to about 80 degrees, the plastic has a chance to stiffen a little more. I wouldn't say harden, but just, yeah, I suppose harden, stiffen, and it'll pop off the bed a lot cleaner. In case you're wondering, my printer is a Wanhao Duplicator 4. I believe it was based off the, is it MakerBot Replicator? It's a twin extruder, but I only use one. Hasn't had a lot of use. It has a couple of imperfections that I should probably address, such as so you've got the rod that runs across, right across to both sides. There's one motor driving a belt driving a gear at the end, and then that runs right across to the other side. There's another gear with a belt that runs down to the same sort of rod across the back side. Now what that does is drives the print head back and forth in this motion, and the rods are quite thin. I think they're 8mm, and the tension on the belt is causing them to pull. The belt tension's pulling at the ends of the rod, so the rod is bowing and it sort of sticks out like that. Not so pronounced, of course, but it's sticking out in the middle, which is causing the belts to run hard up against the end of the gear. So there, the belt's hard over to the inside, and it's the same on the other side. It's hard toward the inside, and I really need to put something in the middle to brace this rod and pull it straight again, because it's also going to be loading the bearing on the end as well. So I'm not sure how long these are going to last if they keep running like that, but it's quite noisy printing. The belt is squealing a little when it's against the pulley, and it is rubbing through. So not the best design, but again, you know, just got to get round to finding a solution. You can see that's broken off already. Now if I'm right, and I think I'm right, the design for the black or minor keys are the same as for the major keys, because the front section is just extended to suit, mating up with the front of the weight. Now we've got to keep these in order, of course, because of the weight cutout in the back. I know we've tested these before, but here's the first one of the final product. Exciting. Here we go. Pop it in, and gotta watch the bottom. Okay, here we go. You gotta watch the bottom edge here on the felt, because with the retainer it does want to push into the felt, so you want to get it over the felt, and then you'll see that this will spring in as it drops down, otherwise you'll end up destroying the felt. First one in, get the first key there. Here we go. C, high C. Get over the front of the weight, pop it down in the back, lock it in. And here we are. Like a new one. Wonderful. So making some adjustments on the fly as you do, because manufacturing is a evolutionary process, you know. You try something, if it works, great. If it doesn't, you fix the design. I was getting some clacking noises on one of the keys, and when I tapped it, turns out that with the original design there, I have not been able to mold around this little hook, this little locating pin, and it was clacking in the little hole that it sits in. Funny that it did on one key and not on a couple of other keys, so I've just put some heat shrink around it. Nice simple fix, so there's no metal on metal there, and it's nice and tight, and we will just test that now and just see if it improves things a bit. Yeah, nice and quiet, but it was quite an audible clunk, so that's good. I may have to heat shrink all of them. Now another tip I'll give you, if you're not going to remove the entire keyboard, so this metal piece here, it's one large structure that goes right along the full length of the keyboard. You could take that out. I would love a workbench that I could pop this on, but I don't have any room and any such thing, so it sits here. But once you start stacking them in, it's real hard to, because we've got the release clip, of course, you can't reach too far in to push that to get it back out. So keep the end one free, pop it in, test it with the key it's going to go with, make sure it moves freely. I've had to make, you know, slight adjustments here. I think the bonding of the seam is makes it slightly off tolerance, so it can bind up a little bit, but just a X-Acto blade and scrape off a little bit of the plastic and it's fine. But yeah, you can test it in the one end, make sure it works before you install it miles down the keyboard where you can't reach it to get it, reach in behind to get it out again. I just found out why I had trouble putting a black key into the space of a white key. There is a subtle difference. So down here, the hook, the width of where it hooks into the back of it is different. So here, the white key is about 6.5 millimeters, and if we were to measure the piece the black key sits over, it's 0.5 mil smaller. So they did make the width in the back of the key a bit skinnier. So in order to do my testing before I plant it permanently in its final spot, I need to I'll be testing here. I'll have to use this end. I'll have to take off the first couple of keys so I can get to it, but that's what I'll need to do just to save any potential headaches. I have found that this is not perfectly stamped out. I guess like with any engineering process, there's room for error, and sometimes they've been getting stuck just in here where it slides in this gap because it actually steps in slightly on each side, and I just had one that I put it in the end here to test it and shimmy it up and get it perfect before I put it further down, as I said, but it worked fine here, but when I put it down the end the key would stick down, and then I found out, well, this is actually not perfect. So you may need to grab a file and just run it against each side a few times just to widen it slightly. It would be a whole lot easier though if I did have this whole chassis out. I think if you have the space to do so, you should do it. I just don't have the space to do so. So this is how I'm proceeding, but just be aware if you have any issues. Subtle things like the manufacturing tolerances there are not perfect or the same all the way down the line. Just one of the small oddities that you get in something like this. So here's two of the minor keys, and may not be so obvious. This is, I guess, you know, subtle differences in the injection molding of these. Where we're looking is right about here. So this piece of plastic, on this key it comes almost all the way out to the edge here, whereas on this key it's actually sitting in quite a bit further. So kind of odd that that would happen. The next black key in the line is the same as this one, so yeah, maybe it was just sitting, something was sitting slightly crooked when they molded the plastic. But the problem that has caused me with the design that I've ended up with is once I pop that in there, get the jaw through the piece there, because that is slightly higher, it won't go in. This corner here is a little too, it sticks out a little too far, because the original shape that was rounded, but I was having a bit of an issue trying to get that perfect. But anyway, I went with square and now we're there. So I'm just going to have to trim or cut that back a little just so that it'll let my print go in. But yeah, when you're reworking something from scratch, these are the things that you get caught out with. So it's really interesting down in the low notes is a lot of the black keys, most of the black keys are actually in really good condition. That translucent sort of, yeah, more translucent appearance. They're very solid rubber, they're not going brittle at all. So, but yet all of the white keys, these ones, look how they've gone all milky and brittle. So I wonder why just those keys. That's really odd. Well, we're down to the last two, and yeah, I don't see any need to replace these ones that are still in really good condition. We may as well make the most of them while they are, and we can always print more later. But it's taken long enough to get this far, so it's just more time to replace the ones that don't actually need it, and we can, yeah, we'll live with those. There's a strip through here which is acting as a guide for the weight. It just sort of, the weight flicks up between a couple of pieces that stick down from this. This end has dulled. It feels like the same material. This end has dulled, and the other end with the high notes is nice and good condition still. So yeah, all round, I don't know, maybe they had no idea this would happen, but who knows. This is not going to be too much of a big deal if it falls apart, but I guess it also acts as a buffer. No, they've got felt running under here, so the weight doesn't make a clang when it hits this. So it's not even used as a stop for the key. So if that did fall apart, I don't think it's going to be a huge deal. How about that? Alright, let's get these on. Make sure they click in at the back. Some of them are a little bit tight. Just pull the key forward. And a lucky last. This one's QC passed. Must have been the best one. None of the others have a sticker on them. I guess that must mean I'm finished. Wrong. In a quick glance, I found that I was still missed one for some reason. Now, for some of the ones that weren't, they were going, but they weren't fully gone yet, then it's still quite a flexible plastic on there, and still quite firmly attached. It wasn't fully brittle to break off. What I found using a putty knife and just scraping it off is the easiest way of doing it. Otherwise you'd be there forever trying to detach it, I think. Gives you a nice wide area of yeah. It beats using something smaller than that, like a little spudger or something, and you'd be there all day. That's what I was using initially, but as I say, they were more brittle. Well, that was lucky because I only just printed one more set because I thought I had everything. Ah well, not like I couldn't print more. And I got the printing process pretty well refined. Like, I was letting it cool down a bit more than I needed to before peeling it off the bed. So I found sort of just blowing some air over the print would cool it off quicker than the bed was cooling down and allowed it to come off without, deforming too much. It would just help it to harden. Just need to finish the end up because, well, that was our test end. So that was our minor key. That went there. That one. I'm going to get the minor key in first. G, A, B, C. Cool. Now this one left over is for there. Now that is the one that I took the original sample from, and it's still in pretty good condition, so I'm just going to hang on to that because it's about the only surviving white key, even though we've got a bunch of the black keys, which is interesting that they lasted longer. So we'll pop that one back in. Although now that I've got it all printed and somewhat perfected, it's not too critical that I have an original of this one. But it's just nice, I suppose, to have. Let's just see how that should go on there. Cool. And it's nice to see that they're all pretty much sitting at the same level. Now I do need to give it a bit of a clean up, so I'll just grab the vacuum and a clean rag and make sure we get up any little bits of broken key. I need some flippin' hearing protection with this piece. I just tipped it up so that all the other broken bits would come falling out one end. So now I've got to get down in there and get rid of all those. But I figured that would be the case. While it's apart, I should really squirt something into the rotary encoder. Having sat for a long time unused, before I took this apart, I noticed that it was skipping and it wouldn't really select or move in the right direction. So contact's probably got a little bit oxidized or something. It is quite a sealed unit, actually. I guess I could hope that I can trickle something down past the shaft. I don't know, don't like my chances. I could actually disassemble it. The rear cover is just crimped over, so that will actually come off. Do I risk it? Not the sort of video I'd actually planned on making. Could do a separate one on this, could I? Well, whatever. I've desoldered the leads. Let's just carefully pop it open. Very carefully. We want to be able to reuse these. And my battery's about to go flat. Ah, boo. So we'll just pry it back as much as we need to get it off, so that I'm sure that somewhat malleable enough to not snap. Now, just in case, put a little mark so you know what way around everything goes back together. Got some blue dots there, and that's going to come off. Ah, look at that, very fine patched contacts in there. Yeah, you can see the rotation there. But it's just two contacts that make and break as it rotates. 3 contacts. Didn't see the other one there. And the offset of when they make and break is how it knows the direction it's going in. Yeah, now we'll give that a light clean. It's not going to need a lot. It's very basic. So right off the bat, there's issues. Something that you wouldn't have thought about, but I did notice, but I didn't think it would have an issue on how it operated. The new key design, the replacement key design that I made, allows for a little sideways movement of the key, and that is causing it to not necessarily hit the button underneath precisely. So you can be and you'll hear a louder note than you expect. So you're using the same pressure and you get that irregular high note, because if you push the key sideways, it creates a contact that isn't expected. And I have also had the effect of just holding it down and moving it. I can't get it to do it, but you get a bit of sideways movement on there. But yeah, that didn't wasn't expecting that. The feel of the keys, the white ones feel fine, but the black ones are definitely heavier. I wouldn't say stiffer, I'll say heavier. Now I did kind of notice that the angle on the key interface there was a little different for the black ones, and I didn't really notice until halfway through, and I didn't think it was going to be that much of a deal. But it does mean that the moment of inertia, how the angle at which it swings the weight is a little different, so that it feels like more resistance to get the weight to move. So here's the effect that I'm seeing. That's fine. But if you hold it down and just side to side, and it's quite loud, so it's definitely not pressing the button underneath correctly. And if you're jumping up and down between chords, you're going to land on them sideways when you push them down, and you don't want to have one odd note just because you do that. One really loud one, like that's quite obvious. So unfortunately it is a fix, but it's not a perfect fix, but it is playable. And I don't know how well the key sound without the volume is coming through like that, but there is some key sound, some noise, some interaction between the new prints. Of course, if I turn the volume down, it's not huge, it's not horrible. And I guess if you're playing away, it's kind of not going to be too noticeable over the sound. But yeah. Anyway, I think that's it. Maybe that'll help you guys find a solution, try and solve your issues. I don't know how many of these turn to dust, but it does seem to be a little bit of an issue out there that I've seen. So maybe I need to redesign things a little, but otherwise it's usable. It's usable for a beginner like me. Give me your comments or thoughts or what have you down below. Thanks all for watching. Hope it wasn't too anticlimactic, but it does the biz. It does the biz for want of a better result. Alright, catch you next time.